Hey, everybody. Welcome back for another speed dating. We like speed dating, don't we, Rick?
It's the best. It's our favorite one. I'm in a bar for speed dating. I'm
I,
excited.
you had to be in a bar, didn't you?
Well, it seemed like the appropriate place to go on some speed dating, right?
It does. So I guess for you, it's totally day drinking because you're in LA. So now I know what you do at work.
Well, you have an excuse a little later in the day for you back in DC. So
Exactly. So for those of you who do not know, my name is Ann Merchant and I work for the National Academy of Sciences. And Rick, you're day drinking also with the National Academy of Sciences, eh?
yeah, so I'm the program director of the Science and Entertainment Exchange, which is a program of the National Academy of Sciences, making Ann Merchant my boss.
Well, and of course, as our employer requires, the first thing that we do is talk a little bit about the academies so that we give our employer its due. And so the National Academy of Sciences is a private nonprofit institution in Washington, D.C. And no matter how many times I say that, I can't tell you how often people will come up and say, so you work for the federal government. But the whole idea that Abraham Lincoln had at that time in 1863 was to create an institution that sat outside the framework of the federal government, so that there was this sort of like big giant think tank at the disposal of the federal government to provide good advice, because the idea was that the policy that the government would be guided by would be made better by the independent advice that came from an institution such as our own. So there's been a lot of work that's been happening right now, obviously that relates directly to the pandemic. But of course, there's a lot of other work that we do on a regular basis. And in fact, the four speakers that you'll hear from today are actively involved in the work of the institution. We have a member of the National Academy of Sciences, May Berenbaum, who is also the editor of the Proceedings of the National Academy of Sciences. And it's a pretty big deal to be a member of the National Academy of Sciences. We also have a member of the National Academy of Medicine, Peggy Hamburg, who's going to be joining us. And we have two committee members. All of the work of the institution is we thrive on the spirit of volunteerism. So Allison Van Nam is a member of our GMO committee, and we also have a member of our Climate Communications Initiative, because Karen is a member of that. So we're very pleased we have four people who are so closely tied to the institution. But we do a lot of disparate work at the Academy. So we have a new report out today, I think it came out today or very recently, on the way in which we're looking at microbial threats that are coming out of the Arctic. As we see the permafrost melting, we know that there are ways in which this will perhaps let loose different bacteria and viruses. So we know for a fact that in 2016, for example, there was an anthrax outbreak that was tied to the fact that the permafrost in Siberia. There were 2,300 reindeer that died as a result, and a 16-year-old boy who was infected. So what more might we experience when other bacteria and viruses are let loose from that? So that's the kind of work that the institution is doing. I should also mention that the National Academy of Medicine just held its annual meeting, and we inducted another 100 people into the NAM, and Dr. Anthony Fauci was the recipient of the Lienhard Award for his contributions. So that was a very big deal. And I think they had a record number of people attend the NAM annual meeting because we were able to open our doors virtually. So the work of the institution is sometimes a pretty rarefied kind of thing, but that's why we created the Science and Entertainment Exchange, to make that work more available to people. And Rick, of course, as the director of that program, you can tell people a little bit about that.
So totally not trying to confuse the two here, but I will say being a National Research Council committee member is an honor in the scientific community, but also an honor in the Science and Entertainment Exchanges community is being one of our committee members, which is not to be confused with a National Research Council committee member. So we have Devin Quinn and Kate Adams helping us out today as provocateurs. So thank you to our committee members, for helping us out. So the Science and Entertainment Exchange is an outreach program of the National Academy of Sciences. It's our job to be the bridge between scientists, engineers, and medical professionals with storytellers in mass media. So if you are writing a feature film, TV show, or video game, you have a question, or a novel for that matter, a graphic novel, if you have a question about science, you can call us and we will connect you with a great scientific mind who will, or STEM mind, who will answer your question for free. We've done that over 3,200 times, including films like Avengers Infinity War, Man of Steel, Black Panther, Captain Marvel, and even the recent release, well, fairly recent, Palm Springs, which I think you can catch on Netflix. Is that Netflix? Anyway, so if you are a STEM professional and you're tuning in for the first time today and you're like, what are these people? Who are they doing? What's going on? We definitely want to hear from you. We're always looking for new volunteers to connect to filmmakers and storytellers. I want to especially thank today all 4 of our speakers who Anne referred to, and our provocateurs for taking time to make this feel more like a cocktail party and less like a Zoom meeting. So thank you for that. Also our AV team at Spark Street who made this thing happen, and the whole team in DC, including Courtney Sloan, Jeff Fishman, and Sachi Gerben, and who's actually in LA. And then finally, I would be totally remiss if I did not thank our sponsors, Howard Hughes Medical Institute, whom today's event would not be happening. Also the Alfred P. Sloan Foundation, Walt Disney Company, Film Nation, Google, Lyda Hill Foundation, Corteva, and individual donors like many of you. And now it's my time to go back to Anne.
Well, and for those of you who have been tuning in regularly, you know that we have made it a bit of a custom to head right down a rabbit hole before we turn to the real order of business, which is our event. And so, and you also know I've been doing some internet shopping, which usually involves something to do with my pantry. But this time I've been sort of beefing up my wardrobe, which includes no pants with buttons, because I'm not into that. However, I discovered this place called Wild Fang, and they describe, so this is the ticket that came with it. It says, "We are Wild Fang, female founded, women run, fueled by the radical belief that a woman has the right to wear whatever the hell she wants, be whoever the hell she wants." So on an expletive deleted, F gender, stereotypes, just do you. But what I especially liked was it says, "The T-Rex in Jurassic Park is a feminist icon." So I'm totally into that. I like that. I like that. And the other thing was I subscribed to a 7-day limited email series called "What Day Is It?" And it's addressing this phenomenon of temporal disintegration, where we can no longer figure out what day it is anymore. It's called Blur's Day. And so these are best practices on how we should deal with Blur's Day. So I really liked that. And the other thing I read about is, should we smile behind our masks? Because there is this notion, and I'm a big smiler when I'm out in public and I see people and I thank them and I'm constantly smiling at people, but it does feel weird. You're smiling back there and you're thinking, well, can anyone tell I'm smiling? But it said that yes, you should smile. And I said this to somebody and they said, well, you know, you see it in people's eyes. But not only that, the whole psychology of it is that when you smile, it actually makes a difference to you, that it makes you feel more socially connected to people. It makes your feeling of isolation reduced. And so you should definitely smile behind your mask. So I've been doing it, and it's recommended for your own mental health. And the other thing is that, so I'm a knitter, and I knit this sweater. I finished it. I felt a great sense of satisfaction for having knit this, and it has all this lace in the arm. So I was very proud of myself for doing this. It took a great deal of concentration. So I can highly recommend anything crafty that makes you feel good. So that's my rabbit hole for the week. And I know you've got some good stuff too, Rick.
Geez, man, that's quite a rabbit hole. That was your level of craft on that sweater is insane.
Yeah, I was pretty proud of myself for this, right?
Yeah, yeah. But by the way, she knitted a sweater also for my 2-year-old, and it is amazing. So I highly recommend that you ask Ann Merchant to knit the sweater. So I just have 2 quick things that I'm going to say, and then we'll get to the real meat of the event. One thing is, a few of you asked me about the electric guitar I tore apart that I showed you a couple of events ago. I just want to say, I did not know anything about electric guitars until I bought this book that I highly recommend, Electric Guitar Setups by Ken Kamamoto. This thing is everything you could possibly know to rip apart your guitar entirely. Do not be afraid. It's not that hard. You can do it. If I can do it, you can do it. The other thing, if I can do, you can do, and I highly, highly, highly encourage you to do, please don't forget, and I know this audience probably isn't going to forget, but please don't forget to vote. please don't forget to vote. I turned mine in California at a drop box at City Hall. You have your own way to vote. Do it however you like, but please vote. Okay, so today's event structure, you're going to hear from 4 speakers. There's going to be a super host who generously this week is Neil Baer, and we thank him for that. The well-known showrunner of Designated Survivor, ER, Law and Order Special Victims Unit, and also you can catch his new documentary, Welcome to Chechnya, on HBO. So he is going to be the master of ceremonies. In just a moment, we're going to turn it over to him. You're going to hear 4 excruciatingly short talks, followed by responses or questions from 4 provocateurs who will be asking questions moderated by Neil. And I think with that, we're turning.
I got to get out of here.
Oh, one last note. You will hear my voice in the background telling people how much time they have. I apologize in advance. It's a little mean, but that's the way we've got to do things with science speed dating. So
I'm leaving and Neil's coming in.
Hi, Neil.
Hello. So thank you, Rick and Ann and the Academy. I'm here to talk about and introduce today's speed dating, and it's all about science is just another opinion. And I'm really fascinated by this topic because I'm a physician and I'm also a television writer and producer. We're at a crossroads today where kind of anything goes. Whatever you believe, whatever anecdote you've heard, that can, make the difference in whether you get a vaccine, think about global warming, and how you deal with COVID. And the problem really now is that because science is just another opinion, or many people feel that way, we're at a real crossroads. And we can see this all happening with the COVID pandemic, where people have heard things, they see things in the media, they see things online, and they don't know what to believe. So we're going to talk today about what the science really says, and importantly, how we can tell science stories that can cut through this echo chamber of chatter about everybody's own experience. We're not saying that people's personal experiences aren't important, because that's how we make decisions, but science is often taking a back seat. And I'm really worried about that. Science is often provisional. And by that, I mean with the COVID pandemic, we're learning about COVID every day. What we knew in March is very different from what we know today. And yet the public often expects science to be definitive. And this is where we're in a real kind of clash, because science is not always definitive. It's often not. It's a progressive, it's iterative, we're experimenting, we're evaluating. And so we have to think about how we can tell our audiences, it's TV writers, that science is not something that is just made in stone. Because I think that will help people to understand that we can do the best we can with what we know now, but that we will move forward and know more. And that's certainly seen with the long haulers. I have 2 friends who have been sick for 6 months, and we just don't know enough yet about COVID-19 to make statements about why that is. So we're going to turn to our first speaker, and we're going to talk about 4 different topics today that are sometimes very contentious in science.
You have 7 minutes.
Hello, my name's Allison Van Nam at the University of California, and it's perhaps ironic that I am speaking to film writers about how to incorporate science into films, given how several movies have represented, or perhaps misrepresented is a better word, GMOs in agriculture. I am thinking of GMO, OMG, Okja, even the famous Jurassic Park, which came out just as I had started my PhD. That one-liner, life finds a way, has been uttered, which was uttered in a 1993 fictional movie about dinosaurs, has been quoted back to me as evidence of the dangers of genetic engineering in animals more times than I care to count. In perhaps the same way that The Martian shall forever haunt potato researchers who are now expected to science the shit out of this. Movies are undoubtedly a powerful science communication tool, and people form their opinions on what they see in the movies. There's a rather famous Pew poll performed comparing the opinions of American Association for the Advancement of Science, AAAS scientists, versus a general public on controversial topics. And GM foods won. Only 37% of the general public thought GM foods were safe versus 88% of AAAS scientists, a 51 percentage point gap, the greatest gap of any politicized scientific topic, including vaccines, evolution, and climate change. It has just become an established fact that GMO foods are unsafe, despite the consensus of every major scientific society in the entire world to the contrary. It is amazing to me that this has been reinforced by marketers for the natural foods industry, and the infamous non-GMO Project Butterfly that is now featured on over 60,000 products, including water and salt. It's an amazing business model to me that food manufacturers pay money for a label that verifies that their product does not contain something that it never contained in the first place. And with that label, they can charge a higher price for that thing that was never there, because unwitting consumers have been convinced that GMO foods are unsafe as a result of an unrelenting misinformation campaign. There have been some infamously bad studies that were designed to create fear around this technology. The grotesque tumor-ridden rats of the 2012 Seralini study come to mind. It was actually that study that triggered me to become involved in science communication. It was an egregious example of parallel science. That is science that resembles normal science, but it differs in that its conclusions precede experimentation. The results are invariably predictable. In this case, it was known that those rats were going to develop tumors as they aged, irrespective of what they ate. Parallel science, sometimes called tobacco science, science performed to obtain a particular outcome, undermines trust in the normal scientific process. I should note that 12% of AAAS scientists did not agree with the statement regarding the safety of genetically modified foods. Consensus doesn't mean everybody believes that. And that, I think, is something that's a little bit unique also to the agricultural GM debate. Everybody has an opinion about food production. Many with no training or experience in agriculture, other than as a consumer or a chef, are very confident in their opinion regarding the best way to produce food. It's a classic Dunning-Kruger effect. And there are so many urban legends about GMOs that science communicators in this field face an uphill battle because most people have internalized the misinformation. Maybe even some of you in this audience. I know that Scott Hamilton Kennedy, who's in the audience and directed the 2018 movie Food Evolution about GMOs, that was narrated by Neil deGrasse Tyson and is available on Hulu if you care to watch it, ran into this confirmation bias amongst his own group of Hollywood friends who were incredulous that he would do a movie about GMOs that was not damning of the technology. It can be very lonely defending science that goes against the confirmation bias of your tribe or peer group. Welcome to my world, Scott. In communicating about GMOs, I've learned that people are often not speaking about their concerns specifically associated with GMOs, but rather the topic has become a proxy for what ails the food and agricultural production system. So what does work? I find that ethical dilemmas posed by the needlessly dichotomous all or none framings. There's a scene in Food Evolution where I am speaking to an Occupy the World Food Prize protester. Ironically, she's holding up a placard that discusses the rats of the Seralini study. And rather than going down that Seralini rabbit hole, I asked her, what is she protesting about? And she spoke about how her family member had cancer and her perception that GMOs somehow increase the use of chemicals in food production. I resisted the temptation to correct that misinformation and rather showed empathy with her regarding her family member. And only after I had listened and made that human connection could we continue to have a civil discussion. I asked whether there were any applications of GMO technology she could support and gave the example of disease-resistant cassava developed by public sector scientists and distributed freely to farmers, an application that requires no chemicals and removed the Monsanto boogeyman from the discussion. And as was shown in the movie, she said she might be open to that. And she said, I appreciate your feedback on this. Maybe it's not an and or. In other words, there may be some applications of GM that I could support. I said, I agree. Can we agree on that? And we shook hands and smiled, and I gave her my card, and she said, thanks, Allison. She was going to do some more research on the topic. As a science communicator, I'm going to take that as a win. Unfortunately, I've also learned that speaking about GMO technology, how it can address food insecurity, is a non-starter. People just are not interested in that framing. And that distresses me as an agricultural scientist, because I went into this field as a result of the dire famines of the 1970s. Even today, 9 million people die of hunger. And to me, it's a real social justice issue that first world activist groups are able to effectively use their full stomach and privilege to block developing country scientists' access to this technology to benefit the world's poorest citizens. This issue is used as a fundraiser in the global north without regard or thought as to the harm of the misinformation on those with no food on the table and no voice in the discussion.
All right, Allison, your time's up. It's time for Neil.
Thank you, Allison. So we're going to move to the provocateurs. You've raised really compelling questions that I'm sure they will be asking you, and I will call on them when they are ready. So here we go. Please, one of our provocateurs, maybe we'll start with Scott. So Scott Hamilton Kennedy. Allison mentioned you, she mentioned your documentary. Can you begin? And I'll throw in some questions too as we move along. Do we have Scott? I don't.
It's not in this room.
Sorry, I went to the wrong person. Sorry, it's just Justin. You know, Justin Johnson. I was looking at the next group. Justin Johnson, why don't you start? Justin.
Yeah, thank you. So when I was thinking about, obviously, there's a lot of things that people find something to hold on to believe in. You know, flat Earth, gluten. Is it bad or good for you? You know, all that kind of stuff. But like, so with GMO, I guess, where is the thing to sympathize over? You know, so this is where it could have negative consequences. So that we can say, yeah, that's there, but then here's all the other pros. You know, and I think if you don't start there, if you don't recognize, like, yeah, you know, vaccines, like some people get sick or it hurts. We know that, but here's the benefits. You know, you kind of like have to at least acknowledge where the pain is first. And if you have a thought about what we can use to start there, but then, you know, kind of go from what are the negatives that do exist, if any. I assume there's some.
Yeah, so I mean, I think what I find really frustrating is that often safety is brought up, and that's really not an issue. There are other issues around, I don't know, herbicide tolerance and, you know, the multinational control of the food supply and large monocrops, those types of general agricultural concerns that aren't actually always necessarily just about GMOs. That's true if you take GMOs out of the picture. But you'll find what happens a lot is that people will use the health concerns to get people worried about it. And there really isn't any science to support that at all. And that's, I think, the frustrating part is because if you can get the health issue off the table, then you can have these more nuanced discussions around these other topics. But if you're being told that they're going to give your kid, you know, I don't know, allergies or leaky gut syndrome or whatever, then you kind of can't get past that, because to me, safety is number one. And then once you get through that, then you can have other more nuanced discussions around it.
Thank you. Anyha, please go ahead.
Thank you so much for that talk. It's very, very insightful. So I had a question about, you know, you go to the grocery store or the supermarket and you see, like, on, as you mentioned, like on cereal boxes and fish and everything like that, GMO free, as if there's like some problem with it. Now, you said that there may not be harm, or like there isn't a harm to GMO foods, but can you go even a step further and say, if you're eradicating an infection that some fish gets by editing the DNA of this fish, are you actually making it safer to consume?
I think you can actually go that far in terms of some of the insect protected crops, such as corn, where you get protected from caterpillar infection, and that prevents a mold developing that can be quite carcinogenic. So that's protecting the crop from that. I can't do it for animals because basically there's no animals that have ever been approved because of this whole debate around GMOs, except for the salmon, which isn't available at this time. And so this debate has really stopped science from using this technology to develop disease-resistant plants and animals. There are some examples of disease-resistant plants like the papaya in Hawaii, but there's only a handful. And then the potential technology has been thwarted by the misinformation and public despair around this topic. And that's what, as a scientist, I'm passionate about, because there are very real consequences associated with not allowing access to safe innovation.
Thank you. I'm going to, please go ahead, Rachel.
Sure. It's my understanding that there's a variety of ways to achieve genetic modification, right? So it's anything from traditional breeding to gene editing with things like CRISPR. Where is the bulk of genetic modification taking place in terms of the technologies that you use to do it?
So the term genetic modification is a very general term. So I would argue a chihuahua is genetically modified relative to a wolf, right? So that's selective breeding or conventional breeding. That's made way bigger changes than genetic engineering ever thought of making. And so that to me is like, you know, huge. But in terms of genetic engineering, where you're introducing a foreign transgene, there's just a handful of crops. And like I said, one animal application. But genome editing is this new and emerging technology that has so much potential, and I am petrified that we're going to lose access to that technology because of this debate around genetic engineering. And so there isn't anything, I think there's one or two commercialized genome edited products, and that's basically just tinkering with the DNA, if you will, rather than necessarily introducing a transgene. But the potential, to me as a geneticist, they all are really useful tools. So why would I take one off the table if it's not associated with safety concerns? And that is, you know, you can tie my hands behind my back, you just make my job harder. And if you're going to do that, then I want a really good cost benefit as to why you're tying my hands behind my back, because otherwise you have to own the fact that we now don't have disease-resistant pigs. And, you know, that's, I think, the trade-off that's often not discussed in this topic.
Allison, if I were writing a show right now and I wanted to draw on like something that's controversial, I might think of unintended consequences. So can you talk about that? I hear that a lot, that we're planning to make a crop more, you know, drought resistant, but there could be unintended consequences. Is that something we should worry about?
Well, I think as breeders, we're always looking at correlated effects or unintended consequences. If you select for fertility, you might, or milk production, you might decrease fertility. So I think that's been used a lot. There's also unintended consequences with doing nothing. And that is, you haven't solved the problem. And so the opportunity cost of blocking access to that technology has to be part of the discussion around it. So this is how I could address that problem, drought, or I could do this. Conventional breeding, what are the pros and cons of both, and what's the cons of doing nothing?
Thank you. So we're going to move on to the next one. That was informative, and there's so much debate about this now, so thank you for giving us a scientist perspective.
Thank you.
Let's move on.
May, you have 7 minutes.
Hi, thanks. I'm May Berenbaum. So with the alarming rise in science denial here in America, scientists can use all the help they can get from among the most successful communicators on the planet, by whom I mean the content creators in the entertainment world. I can't get my undergraduates to use Latin names for insects, but you can inspire them to learn to speak Klingon or speak the 23-letter name of the home planet of the Slithines, among the deadliest enemies of Doctor Who. Today, we're here for two reasons: to help scientists tell the stories of that science is not just another opinion, cut through all the misinformation and political rhetoric to explain how science works as an iterative, self-correcting process, and also inspire the content creators in the entertainment community to take advantage of real and not misinterpreted science to enhance their storytelling. So in the pantheon of science denial, evolution isn't so much a contested field of science as it is a perceived conflict between science and religion. Certainly not contested among scientists, and it's far less contested in the public than it used to be. According to a 2019 Pew survey, 80% of adults say humans evolved over time, and only 18% reject evolution entirely, believing that humans have always existed in their current form. That's on this this percentage that believe in vampires, which is about 13%. And I expect they'll always be with us, but not the vampires, but the people who believe in them. I think the biggest challenge for communicating about evolution is that people don't really spend much time talking about it at all, despite the fact it influences virtually everything we do on a daily basis. If you're looking to rip a story from the headlines, evolution wouldn't seem like a promising place to start. Last night around 10 p.m., I searched Google News for the phrase climate change and hit a story just an hour old, along with more than a dozen less than a day old. By contrast, searching with evolution was a lot less rewarding, particularly after excluding metaphorical uses of the word, as in the New York Times headline, "Evolution of the Onion Sandwich." By contrast, evolution news items are mostly days, weeks, or months old. The latest breaking story I could find was one from Sci-Fi Wire 3 hours earlier, titled, "Why Does Evolution Keep Turning Species into Crabs?" which, as an entomologist, I found interesting. The subject has not been a goldmine for Hollywood inspiration. However, a keyword search of IMDb with climate change as topic, for example, pulled up more than 700 movies. Although evolution as a topic pulled up a surprising 613 titles, the number drops precipitously if movies about cyber-enhanced vampires, werewolves, graboids, aliens, and non-Earth planets are removed. Seems that when people think about evolution, they're thinking of evolution of species, or what's called macroevolution, which is just one part of evolutionary biology. Macroevolution is inherently slow. For example, the Science News story from October 7th titled, "Zoologists Uncover New Examples of Rapid Evolution in Meet the Sulawesi Babblers," describes the finding that male Sulawesi babbler birds on the Indonesian islands grow up to be about 15% larger than the females. But that upgrade took 20,000 years, which is too slow and too inconsequential for a 90-minute movie. But there's also microevolution, changes in gene frequencies within a population over time, the literal definition of evolution, which can take place in months or weeks or even days, depending on the organism, often with enormous consequences for humans. Probably the most familiar example of microevolution, even if people don't call it that, is acquisition of antibiotic resistance, an evolutionary phenomenon in bacteria that is a global challenge responsible for millions of deaths every year worldwide and more than 30,000 in the USA alone. Speaking of life and death, viruses evolve too, and we're in the midst of an evolutionary firestorm with profound scientific, social, and personal impacts. Fortunately, genomes provide a record of past evolutionary events, discoverable genetic footprints that can provide evidence of what happened the same way literal footprints can. Natural selection leaves a footprint in DNA to allow reconstruction of past events. Moreover, unlike physical footprints, genomes as shaped by evolution can provide insights into possible futures with some degree of certainty. So where do you find stories about evolution? Well, I'm the editor of the Proceedings of the National Academy of Sciences, the official journal of the National Academy of Sciences, which is the same organization that created the Science and Entertainment Exchange. Like most multidisciplinary journals, we've been fast-tracking manuscripts related to COVID-19. We've so far published 111 papers on this subject, and every paper published is classified by discipline. And so, surprise, the largest number are microbiology, but more than a few are classified as evolutionary biology. That's because viruses evolve. Mutations alter gene frequency. In June, for example, a team of investigators reported on sequencing the main receptor of COVID-19 virus, called angiotensin 1 converting enzyme 2, ACE2, of hundreds of vertebrates, paying particular attention to the part of the enzyme that binds to this virus's spike protein. The greater the similarity to human ACE2, the greater the risk of spillover. Unsurprisingly, all of the 18 species at high risk were old world primates, great apes, whose ACE2 enzymes have identical binding regions, thank you evolution. But at high risk are whales, dolphins, lemurs, and giant anteaters, some of which are critically endangered. So this one story inspires all kinds of stories, not least of which is the moral dilemma that arises if a viral host is an endangered species. You can slaughter chickens to control avian flu, but what are the ethics of slaughtering the world's last pangolins? For that matter, with respect to COVID-19's origin story, an incipient conspiracy theory positing that the virus was created in a laboratory was stopped or at least slowed by genome analysis. Binding of the virus to human ACE2 was far from perfect and more consistent with the sloppy results of natural selection rather than optimization reflective of a human intent to kill. Now, evolution is among our best defenses against conspiracy theories that could easily lead to hostile exchanges among nations. So in closing, evolution didn't end in the Jurassic, although most of the dinosaurs in Jurassic Park are actually from the Cretaceous. And frankly, viruses versus dinosaurs, or even insects versus dinosaurs, the dinosaur stories aren't nearly as relatable. Evolution isn't necessarily slow and plodding. It happens as we speak. We all now depend on the tools of evolutionary biology to figure out how to meet all kinds of life challenges. So please, whenever you can, tell evolution stories, especially in Texas and other places where ninth graders may not hear about it in school, and help people understand that it's happening, whether they believe in it or not. Thank you.
May's under time. Neil, it's to you.
Thank you, May. Here we go. So, are we ready for some questions from our provocateurs? Let me see. Hands are up. It's hard. Let's see. So I'm going to just call on Scott first, and
Sure.
give us a question, Scott.
Sure. Thank you, May, for sharing that. I think I might only have one question now. I use my daughters 11 and 14 all the time for these kind of questions. How do we reset how we determine a verifiable truth, right? How do we determine a verifiable truth from spin or a conspiracy? What tools can I give to my 11 and 14-year-olds?
Wow. That's a hard one to answer for 11-year-olds. I mean, for me, when I was in graduate school, even though I wasn't in med school, I paid for a subscription to New England Journal of Medicine because, frankly, I hated the spin. I wanted to read for myself, and not have it filtered through reporters who, it's their job to drive traffic and get clicks but that's hard to do if you have at least some passing acquaintance with the scientific method and scientific process. Maybe pay attention in class, and if nothing else, read about science in reputable sources, Scientific American, for example, or others that are vetted. In fact, I teach a class on critical evaluation of herbal remedies, and again, provide the class with sort of a system for evaluating what is a reliable source in terms of looking at the.
Can you talk about your honeybee story? I mean, I heard your honeybee story, and that's a great idea for kids, Scott's children's age.
Oh, you mean in science participation? I mean,
absolutely.
Yeah, so we have a citizen science project as well. Again, trust most university URLs. We have a project that involves anyone who's interested, who has a cell phone or a camera. You've heard about the insect apocalypse or the pollinator apocalypse. There's a convincing evidence of significant, times staggering declines in the diversity and abundance of insects, particularly pollinators. And we're in deep trouble if we lose the pollinators, because of 90% of angiosperm plants, or the majority of plants on the planet, rely on animal partners to reproduce. So bumblebees in particular are in great peril. Not all of them, but there are at least 4 species, one of which is already listed in the Endangered Species Act. One may already be extinct, and there are 2 others that are teetering. So there are not enough scientists, there are not enough bumblebee biologists to get the baseline, to figure out where they are and what their numbers are and what they're doing. So we have this effort to recruit citizen scientists, anybody with a camera and an interest and time, who can distinguish a bumblebee from most other insects. Just go and take a picture. It's maybe harder than you think, but one of the very first pictures we had was a carpenter bee, which looks a lot like a bumblebee. But take a picture, it's geo-referenced, upload it, and that will allow us and taxonomic experts to find out where the bumblebees are, at least in the Midwest states. it's not systematic, but every bit of data is useful. So anyone can help with this project. It's not like you have to know sophisticated modeling for climate change. Take a picture and upload it. That's a datum. That's a data point, and we can use it, and it's incredibly valuable. And
fourth graders can do it, right? Fourth graders can practice scientific investigation. We're going to move because we're running out of time. So next, who else has a question? I see. Okay, so Cynthia.
Hi, thanks, Professor Barenbaum, for that. As I listen to you, it sounds like using microevolution seems to be a good case for the integration of biological sciences and the social sciences or the humanities in many ways. If I'm understanding you correctly, I think the microevolution argument is one that kind of makes it real for all of us all the time. Am I correct about the interpretation?
Absolutely correct. And in fact, some intelligent design advocates will grant that microevolution happens.
I'm curious to what you think about that, and it kind of leads to a bigger question, which is, oftentimes as social scientists, we think about how people think about the impacts of politics, if people can evolve mentally, if they actually do, in what ways, positive or negative. And your antibiotic comment is interesting because if something can happen that quickly, what about humans and our emotional states, our mental states? I mean, that's to me fascinating.
What's interesting, I mentioned the 111 papers that PNAS has published on COVID-19. A significant slug, possibly more than microbiology or social science, because there is nothing we can do about this pandemic without sign-on from the public. Look at the mask debate. Look at the vaccine. You'll hear about the vaccine debate. So it is utterly essential that biological science partners with social science. All kinds of science has to partner because, ultimately it's, we are anthropocentric. We can't help it. That's one reason the further away you get from humans, the harder it is to write a story people care about. It was one reason I didn't talk about insects as much as I would have loved to talk about insects during my 7 minutes, although the challenge would be to confine it to 7 minutes. So, but yeah, your excellent point. Humans are tough. I mean, it's hard enough to go from caterpillars to bees because of the exceedingly complex social behavior of bees. But that jump to humans, going from 6 legs to 2 and going from, the human brain is orders of magnitude bigger than the bee brain. So I, as an entomologist, am reluctant to make that leap, but I do say the social sciences are absolutely critical.
Thank you, May. Thank you all. We're going to move on. Yes, that's it.
Fast.
Peggy, you have 7 minutes.
Great. I'm Peggy Hamburg, former commissioner of the FDA, and this afternoon I fear that I may be the nerdy Debbie Downer that nobody wants to date, but I'm going to talk about COVID and vaccines. As we face a third devastating surge of COVID-19 in our country, it's hard to remember how it feels to just go to the movies, get on a plane, or even send our kids to school without worry. Many are pinning their hopes on a vaccine to get us back to those earlier days. The good news is that we will almost surely see a COVID vaccine soon, likely more than one. But let's put this in context. As much as I believe in the power of vaccines, this will not be a magic bullet that will slay the virus swiftly and completely. We need to be realistic, but we can also be optimistic. The mobilization of the biomedical research community to rapidly develop COVID vaccines has been incredible. A large pool of candidate vaccines are now in development, and there are almost 12 in late-stage clinical trials. Additionally, billions have been invested to start large-scale manufacturing of the most promising vaccines before we even know which ones may cross the finish line, so that if successful, they will be ready as soon as possible. But making a vaccine is a complex, lengthy process, starting with basic test tube studies, then animal studies, and then a phased up series of studies in humans. Typically, it takes a decade or more. The fastest vaccine ever was 4 years for mumps vaccine. But the urgency of COVID has dramatically accelerated timelines, compressed phases of research, but still making sure that the critical scientific questions get asked and answered. And the hope is to set a new record for speed without cutting corners for safety and efficacy. But even as we race toward a vaccine, we must be grounded in the realities of what a COVID vaccine will mean. Many assume that a vaccine will be fully protective, that it will prevent you from getting the disease, but it's not so simple. Measles vaccine is about 97% effective, but flu vaccines vary year to year, generally between 40 and 60% effective, depending on the recipient and the season, and the same may be true for COVID vaccines. Undoubtedly, partial protection would make a huge difference in disease control. FDA says a COVID vaccine has to be at least 50% effective. That means that many would not be protected. Moreover, the vaccine might not completely prevent disease, but rather reduce the severity of symptoms or the length of disease. Again, this would make a real difference, but it's not the panacea that many are hoping for. And if vaccinated people can become infected, they may still be able to transmit disease. So even after we get vaccines, expect that for quite a while, you'll still need to social distance, wear masks, avoid crowds, and wash hands so that we can limit infection and ongoing spread. Over time, we will develop new, better, more protective vaccines, but that will be the reality for now. And while I'm being the reality patrol, I have to add that the most promising current vaccines require 2 doses spread over time. So vaccine immune protection won't happen straight away. But perhaps more significantly, even with early investment in manufacturing, once a vaccine or vaccines become available for use, supplies will be limited. There won't be enough for everyone. So who should get the shots first? And will some not get vaccine? This will be messy. Big picture, rich nations like ours will probably try to outbid poor nations to secure vaccine. Although in a global pandemic, no nation can be truly safe until we control the virus and its spread wherever it is in the world. And within our borders, triaging scarce vaccine resources will be tough. Most will agree that frontline healthcare providers should get early access, but what about other responders? What about other essential workers who may not wear uniforms but stock our grocery shelves or deliver packages? What about those most at risk because of age or other diseases or living in crowded settings like nursing homes or prisons? What about Black and Latinx populations who suffer a disproportionate burden from COVID? Should they go to the front of the line? These questions must be addressed sooner rather than later, and answers will reflect matters of public health and disease control, but also ethics and justice, and probably politics. Distributing the vaccine will be challenging, but we need to do it as swiftly and surely as possible, tracking who gets what and when, both to make sure that people get the right vaccination follow-up, but also to be able to have ongoing monitoring, to look for emerging safety concerns, and to see how the vaccines are working, how well, for whom, and for what duration. This is standard practice because we always learn more when we move from a limited controlled clinical study into larger and broader community use. But this so-called pharmacovigilance is especially important with COVID because the vaccine development process has been so accelerated. And this brings me to my last point. Even the world's most safe and effective vaccine won't make a difference if people don't trust it and therefore won't take it. Long before COVID, an anti-vaccination movement was putting out misinformation about vaccine safety, tragically leading to underimmunization of kids with resurgence of serious preventable diseases like measles. During COVID, the anti-vax movement has been busier than ever, but additionally, the push for speed, along with visible pressure from the president and others, has led to new distrust and vaccine hesitancy. In a recent Pew poll, only 21% said they would definitely take the vaccine, and that's half the number from only 4 months ago. We must rebuild trust by having the politicians get out of the way, allowing the scientists to drive the process, and engage with the public in an open and clear manner so that they know what to expect and why the vaccine will matter. Vaccines have helped fight off deadly scourges like smallpox and polio, but the process takes time and there are no guarantees. A safe and effective vaccine is within our grasp. It may not be a magic wand, but with clarity, trust, and good science, vaccines will still play a substantial role in reducing the epidemic and giving us back our lives. Thanks.
Thank you, Peggy. So we're ready to go for some questions here. So anyone ready to start? How about Kate?
The joy of having a last name with A. Peggy, thank you so much. That you packed a lot of things that I wish I had time to delve into, but I'll start with where you ended, which is trust. And like, how do you see, I mean, I think a lot about social media. I think about the fact that, you know, we talk about scientists being people that we should trust, but still people don't. I think there's fortunately a good amount of trust in what Fauci says, but if who else can we be looking to when you have people believing QAnon conspiracies to get the word out about when it will be safe, when it is safe, because I'm also a questioner of how fast we're moving. You know, what do you recommend? How can we be helpful as entertainers? Anything you want to touch on?
Yeah, well, it's such an important question. It draws on some of the issues that have already been raised by others. It's really important that people understand the process, and science is an iterative process. And sometimes when information changes, people think I can't trust the science, but it's just the nature of science. People also need to hear clear, consistent messages from people that they trust, people that they understand them. And as scientists, we sometimes think if someone isn't coming along with us, whether it's about GMO food or climate change or whatever, that they just aren't listening carefully, they don't understand the facts, maybe we haven't presented them in the right way. But it's also that maybe the message isn't coming from the people that they really resonate with. So when we think about vaccine hesitancy, we have to think about not just having people like Tony Fauci, who's demonstrated his trustworthiness by speaking straight to people and telling him what we know and what we don't know, giving bad news, but trying to explain what's going to be done to address those problems and how you yourself can help reduce your risk. But it needs to be more than that. We have to go into communities. We have to find the leaders, whether they're faith leaders or community leaders or even barbers or others that people will listen to, and make sure that we have those connections being made. And I really do think that it's become a very dangerous situation. It's not just in this country, but around the world, where people toss off scientists and scientific expertise. Maybe it's because they don't like authorities in general. They don't want to be told what to do. Maybe it's because scientists over time have been kind of patronizing. Maybe it's because we really have to pay more attention to what was raised earlier about people seeing things through whatever tribe they belong to, the political or other ideologies. But again, that means not only do we have to think about the message, we have to think about the messengers.
Like our beloved characters we write for on our shows, and people believe them. And we want people to really suspend belief and believe what our characters are saying, but we want them to say things that are accurate.
Right.
Thank you. Lisa, please.
Hi, Dr. Hamburg, thank you so much for that. I was wondering, I have sort of a two-part question. First of all, like, So we're looking at maybe 50% efficacy for a vaccine, and the endpoint is not preventing the disease, but maybe preventing death or preventing serious symptoms. So what sort of how many people, what percentage of the society needs to be vaccinated for us to get that to get the benefit?
Yeah, well, first of all, we're talking the minimum threshold. We hope that these vaccines will be more protective, and we hope they will actually prevent disease. But we recognize that, especially in a pandemic like this one, we can't let the perfect be the enemy of the good. We need to help build that so-called herd immunity, the protections in communities to slow spread and prevent infections. And this will help. You need, over 60% to really begin to meaningfully slow spread. There's been a lot of debate in the press and unfortunately in the White House as well about whether just go with herd immunity, let people get sick, maybe protect the most vulnerable and keep the elderly at home and others. But that would mean a lot of people getting sick, some with very serious disease, some with long-lasting consequences and organ damage from COVID, even if they didn't have severe disease in the first place, and then many, many deaths. So the vaccine is a much more meaningful tool. But why I chose to talk about what I did is that people need to understand that vaccines are not silver bullets, that especially in the beginning, we're likely not to have the best vaccines that will develop over time. And so they're going to be staged in. They're not going to get us where we want to get to as quickly as we need. And that's why we're going to have to marry vaccines with those other public health measures as we go forward. And we need to still work on therapeutics so we can treat disease more effectively as well. And in my view, we need to also not just think about protection and herd immunity in our own country, but really this is a global issue. It needs a global solution.
Great. Next question. Lo.
Hi. Nice to meet you. I'm a mathematician. And so actually, but I'm going to ask a question that's more on the behavioral side. I think it's very interesting what you said, that the vaccine's not going to be a silver bullet. Unfortunately, I think a lot of people in this world are thinking that I'm just going to have to hold out with this funny way of life until the vaccine, and then finally I'll get to have a party. But now the thing I'm a little concerned is if the vaccine has an efficacy that is not, all the way there, and if not everyone has gotten it, if then everyone says, okay, vaccine is here, I got it, I'm going to go and have a party, actually you could have everything blow up even worse. So should we already right now be having everyone say what you have just said, because you're the scientist, right? But should we start echoing this everywhere? Because the communication I see everywhere else is, let's just be careful until the vaccine, and then finally we can stop.
Yeah, well, I'm a great enthusiast about the power of vaccines, as I said, but I do think it's important to get this message out, because if people don't understand the limits of what especially these initial vaccines will bring, then we might actually see a worsening of spread and certainly a persistence of this disease in communities. So it's very important that people understand and take the precautions that they need to, even as we move into a world of increasing vaccination. And the more vaccination there is, the better off we'll be, even if it isn't completely protective. I also worry about it in terms of people's confidence in science, when they hear over and over again that we just need to wait for the vaccine, and then bang, suddenly they realize that the vaccine isn't going to protect them completely, and it's not their ticket back to everything they used to love to do and put on your party clothes and get on that airplane. So I think we really have an obligation both to help people understand their own risk and what they need to protect others, but also to help them understand what is the scientific process, how do vaccines work, how are they developed, and how we can keep investing in the science to develop better and better, more protective vaccines over time.
Thank you. Mike, quick last question, quick last answer.
Sure. Super quick. I guess just to piggyback off that, do you feel like sort of the over focus on the vaccine is part of why people are thinking it's a silver bullet? And if so, what other things should we be talking about in terms of treatment or in terms of other sort of risk assessment measures that can mitigate that fear?
Yeah, well, it's an important issue because I think, you know, so much of how we have dealt with this pandemic has been to raise hopes and then they get dashed. And I think that's dangerous. I mean, this vaccine is going to be with us for a while. We're learning more and more how to manage it, but it's going to require a textured, multifaceted approach that's going to be public health measures that don't involve drugs or vaccines. It's going to be new, better drugs, both to treat early on, maybe even some drugs that can reduce your risk of getting infected, sort of like a bridge to vaccines, like the monoclonal antibodies that the president got. And then, of course, vaccines. Vaccines have been, you know, really one of the most powerful tools of medicine and public health in human history in terms of helping people lead healthier, more productive and longer lives, and saves, you know, millions and millions of lives every year. So it's not wrong to think that vaccines will have huge value, but they aren't the silver bullet. Likely the first vaccines won't be, you know, as protective as we would like, as I said, and you can manage certain infectious diseases without vaccines. It's better to have a vaccine, but we've seen with HIV/AIDS, which, you know, was what led me into public health and public service, watching that terrible global pandemic unexpectedly emerge. You know, we took what was a always lethal, devastating, terrible disease, and it now isn't something you want to get, not by any means, but it is a chronic manageable disease thanks to better understanding of the nature of the disease and drugs that actually make a difference and work.
Thank you all very much. Enlightening. We'll move on to the next and final topic, which is global warming.
Karen, you've got 7 minutes.
Great, thank you so much. It's a really pleasure to be here today. So my name is Karen Akerlof. I am a social scientist who studies science and risk communication at George Mason University. I'm going to tell you a story about how I have come to think about telling climate stories. And it actually somewhat parallels the development evolution of the field of climate communication itself. So I actually started about roughly 15 years ago or so studying this area. So my story and the types of social science questions I ask started with an interest in science and media. So I was pre-med in college, probably did not do as well as Neil did. But I also worked as a writer and editor at a college newspaper, in fact, a couple of them. So instead of applying to medical school, I decided to work for a medium-sized regional daily newspaper in California, which actually, unfortunately, doesn't exist anymore. As you may all know, that local newspapers have been disappearing for quite a while. I soon discovered that the paper ran regular articles on paranormal phenomena in its features section. And they were immensely popular. In fact, I literally got a call from someone saying, this is, you know, the greatest section that you actually run in the newspaper, in the featured section. At the same time, the paper mostly ignored the science being done at the university down the road. It was a very large, very relatively prestigious university. But I also found there were other ways that science reporting might slide in. For example, coverage of a release of an IMAX movie on sharks might lead to a big spread in the feature section, including a discussion of their ecology. And I would actually get to call up scientists on the phone, which was fun. So after some years, I decided to go back to graduate school. In order to get a better foundation in environmental science and policy, I like the shark story, with the goal of becoming an environmental journalist. Climate models, as you probably know, underpin climate science and policymaking because they allow us to get a glimpse of what the future may hold across different scenarios. So in graduate school, I studied how newspapers and other media outlets were reporting on climate models, or actually rather not reporting on climate models, and discovered that among the media sources preferred by high political knowledge audiences, policy wonks, in the United States, the outlet with the most explanation, who did the best job of actually like trying to tell people how climate models actually worked, sort of take things out of that black box, was actually the Rush Limbaugh show. NPR's Science Friday was next in line. As you might guess, the purpose of Rush Limbaugh's discussion of models was to poke holes, right, in climate science. We found, in fact, that there weren't many journalists who wrote on climate models. And the numbers soon dropped even more, because around that time, just as I was thinking I was going to finish up this portion of my graduate career and go be an environmental journalist, traditional news media markets absolutely cratered, and scientists and environmental journalists were just laid off in droves. So I stayed in graduate school. I wondered if news media are limited in their ability to provide decision makers with scientific information on climate, per that last study. What are the contexts that are likely to be more successful? One of the underlying ideas in democracy is that citizens should play a role in issue deliberation, AKA as sort of the voice of the people. Deliberation exercises bring members of the public together to consider issues of importance and develop informed preferences, i.e. facts help in thinking about what should you do as a society. Ideally, when deliberation is done well, the decisions that the public makes then are also conveyed to decision makers to be incorporated into policy. We surveyed residents of a coastal county on their understanding of sea level rise science and preferences for policy options. We then invited them to participate in a deliberative session. Over the course of the day, the residents worked in small groups to discuss the information they heard from experts, maps showing local impact projections in the future, and materials on the science and policy options. At the end, we then surveyed them again to see how their risk perceptions and policy preferences changed. We found that across all the county residents, living close to flooding hazards significantly predicted or was related to respondents' perceptions of household or neighborhood risks from sea level rise, but not of risks to the entire county. And that may sound kind of wonky, but if you think about it, counties are actually one of the typically the smallest units of governance we have. It doesn't maybe get down to a town. It doesn't get much smaller than that unless your HOA happens to have an active climate change policy. But in this case, the scales with which people were good at detecting flood risks and their implications for policy were even smaller, that of their household or their neighborhood, which, as I said, doesn't have necessarily a lot of policy relevance. On the other hand, we also looked at their cultural worldviews. That is, their beliefs about how society should be structured that are often run fairly highly correlated to things like their political affiliation and their political ideology. And we found that their cultural worldviews were highly associated with their risk perceptions across all levels of their risk perception, from whether they were thinking about the risk at their home, their neighborhood, or their county. So we then looked at the effects of deliberation on the group as a whole. So what happened to these people? So they went through this exercise, they came out. How did that change? They went through a day of thinking about this problem as opposed to seeing a newspaper article or seeing a sign or maybe an ad. Interestingly,
you have 1 minute.
the event, sorry?
1 minute remaining.
Great, thanks. Interestingly, the event significantly increased problem identification and concern among sea level rise impacts among those people who held worldviews predisposing to lower environmental risk perception. In other words, we essentially decreased the effects of polarization from worldview. My suspicion was that it wasn't just the information we provided per se that caused people to shift their issue concern, but the social process of talking to other people in the groups. Research have found that the perceptions of social consensus can play a large role in influencing people's attitudes and behaviors. By social consensus, I mean the norms of a group in terms of its predominant beliefs or behaviors. For example, half or more of US citizens have worried a great deal or a fair amount about climate change for roughly 3 decades, according to Gallup data. But people don't always have a good measure of what other people think and do, especially on climate change. The percentage of climate scientists who say that climate change is happening is one form of social consensus, that of experts in the field. Another type of that is that of the beliefs and actions of people in a region, state, or country. We found that people were vastly more likely to be aware of the scientific consensus on climate change than the social consensus. Further, the perception of social consensus within regions of the state was related to climate policy support at a level that was equally or marginally less than that of scientific consensus, which means we can't remove science from its social context. For storytellers, it's particularly good news because it makes for compelling narratives that can compete perhaps even with the paranormal. Increasingly, communities, whether local governments, businesses, or universities, are discussing climate science and policy options within the context of what are we going to do next. The discussions around these decisions present enormous opportunity to highlight science and its social dimensions in ways that make for captivating storytelling that could also inform public discourse.
Thank you. Let's have some questions. Oh, it's Heather.
Mute.
Heather, you're muted.
Unmute. Okay, there you go. So I like, I like the idea that to change people's attitudes, and from my understanding, from neuroscience in the brain and psychology is that it often happens in an unconscious way. And I think one of the things is like the greatest predictor of whether you're going to have solar panels on your house is whether your neighbor has solar panels on their house. So I like the idea of thinking of strategies of how to, instead of just having a scientist tell them the facts and the data, but having these sort of unconscious ways that people can get the information across. So my question is, in terms of actually having a policy impact, what do you think is more important? Is it more important to try to focus on ways that we can change people's attitudes in the general public, and maybe that's through media or various other means, or is it more important for scientists to have a very strong dialogue with the politicians and the policymakers, or both? But just in terms of like where our energies should be in terms of getting the message across and changing and leading to policy change ultimately.
So there's been really some interesting literature around what are the effects of public opinion on policy. In fact, Leah Stokes and Menno Milderberger and some others did a paper looking at to what extent is public opinion on climate change reflected in the way that congressional offices and their chief of staff think about these issues. So, I mean, there is evidence, so people have looked at this question for a long time. There is evidence that public opinion, obviously on some level, policymakers are concerned about being reelected. And so going way out far of where the public opinion is potentially is dangerous, but they also found that that chiefs of staffs and offices don't seem to be particularly reflective of their understanding of where their constituents are in those issues. So I think one of the neat things though is that we do have a lot of options or levels of decision making, which are cards, not just all at the federal level, and that's already been happening. And so people do have opportunities to get involved in making these decisions, which I think make this a much real problem and also make people feel more efficacious.
Thanks. Next question. Cecil.
Hi, thanks so much for that. I'm curious about, it oftentimes feels like we're in the sort of slow boil, like every single year things are changing, but it's so slight that, until it gets very big, especially over the last 100 years. So I'm wondering, how do stories from, let's say in a small town in this social aspect that you're talking about of like, well, the lake used to be like this and now it's like this. And how can those kinds of stories sort of help in making people believe that there is actual change when it's hard for some people to see the incremental changes?
Yeah, that's a great question. And that's one that people have been, so the assumption was that if you, and it still is, many people assume, so that if you point out the local changes, that it will also bring it home to people, that their risk perception is more likely to be higher if they think it's, this is something that affects them as opposed to people and places far off. So I will say, number one, going back to that problem that we don't have a lot of local newspapers anymore. So the places that would do that kind of reporting have sort of disappeared. There also, I will say, is some conflict in the literature. So people have been testing the question, if you give them information about local effects versus global effects, how does that relate? to people's risk perceptions, their interest in doing something. And there is some level of conflict where some studies say that it really is influential, and other studies seem to indicate it's not. I do agree you're right, that's sort of the shifting baseline phenomenon. People don't know what it was necessarily, they don't remember what it was like. I mean, that's certainly also a very valid phenomenon. And I don't know of any studies that are particularly have pointed out that we're seeing that in terms of at this point, but I think it's a really important point.
Thanks. Ariana. You're muted.
I don't have a specific question, but what I'm interested in is when you were talking about journalism and how there's a big shift in journalism, and it makes me think of decentralized information, and I just am thinking about I think how it's so fascinating how science, the technology aspect of science brought us like social media, and as that's expanding, it's decentralized our information. And so now we're in this moment where, I mean, some of the most seemingly logical people I know are just completely think there's a conspiracy, and that the vaccination is a conspiracy, and science, all of it. And so I'm just I guess what I'm trying to understand is an example of something really positive I saw was an indigenous leader from the Amazon was featured on Time. And then some fashion publications and different people started to write articles about this woman. And a lot of people read a letter she wrote the other day. And then it led me to her social media page. And I was so excited to follow this woman in the Amazon. So I guess that's I don't have a specific question, but that's where my mind is going as you're speaking. And I wonder if you have any thoughts about that.
I think that's a beautiful example that's so positive too, that you found somebody else, speaking these other voices. And I think, coming back to that social consensus idea, the more that we hear voices from people saying this is something that we need to address, that's sort of reinforcing, even if we don't necessarily think, now that I've heard that one person say it, I'm more likely to do X, Y, Z. It's sort of as Heather was pointing out, it's sort of this unconscious, we're constantly looking for essentially what's the social norms around us. And I think that's the other thing that, on the negative side, right, is that we're all choosing our own sources of media. And so the social norms within all those groups is so vastly different. We don't share the same, right, necessarily the same belief structures, necessarily even think of reality quite in the same way. And so I think that's obviously, that's one of the downsides. So it has these positives and negatives at the same time, unfortunately.
Thank you. We're going to wrap things up right now. So thank you all, the 4 scientists and the provocateurs, for this conversation. I'm left with Peggy Hamburg's statement, we can't let the perfect be the enemy of the good. And I think what's so important about what's been said is that science is iterative, it is accruing, and often the public wants facts that are immutable. And we, as writers, can get that point across. And I think that's one of the most important things that I've heard today from all of the scientists, that we are always gaining new knowledge, and that we can do the best we can with what we know now, always looking forward. Otherwise, we wouldn't have better treatments for even COVID. We didn't know about dexamethasone until, after many people had sadly died, but we learned, and now fewer people are dying, fortunately, because we're using this drug. So I think that's really important. I'm reminded back in 2000, when I was doing the show ER, that we did the first study that looked at, what do people learn from our shows? And it was an episode about human papillomavirus and cervical cancer. Before the show aired, 9% knew that HPV caused cervical cancer. After the show aired, it was almost 30 to 40%. We also found out that people could define what HPV meant after the show aired. It was the first random sample that was done. We also knew that 1 out of 4, when we did this study with Kaiser Family Foundation and Princeton Survey Research, went to their healthcare provider to talk to them about something they saw on our show. So we really do have the power to help shape the narrative. And it's important to shape the narrative in an accurate way, which gets back to what the National Academy is doing. We need to present accurate information because people believe what our characters are telling them. They believed what George Clooney was saying on ER or Mariska Hargitay says on SVU, and I was really aware of that. And it's wonderful, but it's also a huge responsibility for us. So I think in closing, I recall when I did SVU, I wanted to do a show about vaccinations. And so I wanted to talk about what is the responsibility of a parent to their child and vaccinating their child, and what is the responsibility of a parent to the community of children. And so I did an episode about a mother who didn't vaccinate her child. That child exposed a baby, and that baby died. So we can take the science and we can shape stories to make a difference. And we can put out there these complex ethical dilemmas that we all love to do. Is it just for our own children, or is it the community of children? Is COVID just about our family, or is it exposing the community? And when we start to take the science and the accurate way of presenting it through our stories, I think we can make a big difference. So thank you all again for stimulating us to tell tough stories that I think can make a difference and to help people really understand also what science does. This notion of science partnering with social sciences and the arts and humanities is really important. We can tell and show how our characters make decisions by what they hear and what they see. So thank you again, and I'm going to turn it over to Anne and Rick for concluding remarks.
Thank you very much, Neil. And you've spoken to exactly what the mission of the Science and Entertainment Exchange is and what we do. And when you cite some of those stories in Law and Order Special Victims Unit, those are exactly the things we talk about when we go out stumping for the exchange, and we cite your work all the time. And we're so grateful to the fact that you've been a friend of the exchange for a long time. I remember many years ago, you were so generous with your time coming to the National Academies and standing on our stage and talking about your work and making it relevant to our audiences. So we're always grateful when you come back and you give of your time. So thank you very much. And thank you to all of our speakers and all of our provocateurs. It was really great that you were here with us and making all of this science relevant to everybody and to everything that we do and try to make clear to our audiences. So Rick, I don't know, you've probably been drinking this whole time back there in your bar.
Yeah, this bar has been great. This bar has been great to me during this whole event. I don't know what you all have been doing. I do want to thank a couple of things. So one thing is our provocateurs. I know we didn't get to everybody because we were running so excruciatingly short on time. Our apologies, and thank you so much for taking the time, especially for those provocateurs that didn't get a question in on screen. So thank you for taking the time. I also wanted to thank all of the supporters, all the folks who joined at the supporter level. I forgot to say this at the beginning of the show, but this is vitally important. You are critical in keeping these events going, so thank you. And if you do join at the supporter level, we will send you one of these, give you access to some exclusive VIP Q&A sessions, and also we're working on a VIP event for that group that joined at the supporter level. And also next week. Yes, yeah.
That's right, because Bill Hallman, who is frequently on our committees, he is a social scientist at Rutgers University, and he will be joining us for an event that we're calling Risky Business, the science of risk assessment. And Ahmed Best will be joining us in conversation with Bill, and then we'll be doing a VIP Q&A after the event, because as you've already seen today, we just can't get to all the questions. So there'll be more information in our invitation that goes out after today's event. So thank you for being here. We'll have more for you next week, and we hope you come back.
See you next week, everybody.
Bye.